on this video, we are going to learn about sets. One may ask, what's set? Set is a form of roots, but on non-perfect roots. That's, for instance, let's take example of root 25. It's perfect in a such a way that if you have the root of 25, you know our answer is 5. But let's take, for example, root of 2. You can't determine the figure of root of 2, but you get decimal. That's non non-rational, this one root. We call them sets. You back. So most of the times sets are root of prime numbers. Most of the times if you find set, they are almost root of prime numbers, and that numbers to, if you multiply them, you most of the times get sets. So with all this introduction, I'm going to take you through whatever you need in sets. So let's dive into it right now. So let's start. So set, reduction to the basic form of set. That's the first thing we are going to do. Reduction to the basic form of set. So if root x is such that it cannot be reduced further, then it's said to be in the basic form. Thus, it does not have a factor. For example, let's take root 2. You know that 1 times 2 will be giving you 2, and root of 1 is 1, and multiplying 1 times root 2 is the same as root 2. So this is the basic form of this root. And let's take root 24. Root 24 has a perfect square and also a factor that this one, a set in it. So we can say 4 times 6, which is giving us 24. So the square root of 4 and the square root of 6. So the square root of 4, which is 2, and the square root of 6, which we know that is irrational. Don't break it down, but we just leave it like that. So our answer is 2 root 6. If it does not have factors, it means it cannot be reduced. So we say that it's unit or basic. So one of the factors must be perfect squared. So always know this, one of the factors of the number must be a perfect square. Take note of that. So note here are some perfect squares. So let's take root of 9, which you all know that is 3. It's perfect because whenever you take the root of it, you are getting exact number, not decimal or let's say a fraction. You get, so the root of 9, which is 3, the root of 36, which is 6, the root of 81, which is 9, and the root of 16, which is 4, and the root of 49, which is you can mention what have you. And also note the routine that I'm using. It's actually the, let's take 16, root 16 is equal to 4. So it's actually 4 squared, and you root the square of the 4, which is root 16. That's a perfect square. So let's take illustrative examples. So let's simplify this. So question 1 says you should simplify root 27, and question 2 says that let's simplify root 32, and question 3 says that let's simplify root 8. So solution, root 27 is equal to the root. We know that you have to always, the factors must be, one of them must be a perfect square and one must be just an irrational number. Most times it's a prime numbers. Okay, so let's go. So it's actually 9 times 3. So the root, you share it for both of them. You know that root 9 is 3, and root 3 you just leave it like that because it's irrational. Leave it like that. Also, let's go to the second one, which is root 32, which is equal to 16 times 2. Root 16 is 4, and root 2, you leave it like that. Work out the solution for the last question. You know the answer is to be 2 root 2. So work out. When you don't get 2 root 2, it means that your answer, the work you are doing is wrong. So take note of that. Addition and subtraction of sets. Let's move on. Note, we always add and subtract sets which are alike and have the same form. So let's go. The first one says that m root k plus n root k should be equal to m plus n root k. Why? Because they have a root. The roots are the same. That's k, root k. So you just add the, let's take it as the coefficient. So you just add the coefficient. That's n plus n, getting n plus n root k. Verb 2. M root k minus n root k should be equal to m. Yeah, the same applies to the subtraction. So take note of that. Also note the first, we reduce the set to the basic form. So when solving, you have to reduce them to the basic form. Note, root 5 plus root 2 is not equal to root 7, or the otherwise, which is the subtraction way, is not equal to root 3. Since they are unlike. Sample questions to solve. So we are talking about addition and subtraction of sets. So we are taking example questions to solve, to try and answer in order for you to understand. So I, which is 5 root 2 plus 3 root 2. So solution, we know that the coefficient, let's take them as coefficient. 5, the coefficient of root 2, the first one is 5. The coefficient of the second root 2 is 3. So you add them and you multiply it by the root 2, getting 8 root. 2 rather. So 4 root 3 plus root 3. So you take the coefficient, the second one is 1, the coefficient is 1, the first one is 1. So add them, getting 5 root 3. So these are a sample of question that I want you to try your hands on. So the first one says root 5 plus root 5. What's the answer? And the second one says root 5 root 3 plus 4 root 3. And the third one says root 3 minus 2 root 3. The fourth one says root 5 plus root 30. And the fifth one says root 50 plus 32 minus root 162. So solve it, and if you have any problem, just I'll be posting my number into the description link, so you can chat me and I'll address that issue. So let's move on. Multiplication set The multiplication set rules. So these rules should be noted always when solving multiplication of sets. So the first one says that root a times root a is since they are like, you just take one and square it, and the square 2 cancels the root, getting a. So actually root a times root a is equal to a, and this one too the same way, you can cancel it, getting a. But this one they are unlike, so you just take the root and multiply the numbers in the root. So root a times root b is equal to root ab, and root a on root b is equal to the root bracket a on b. Let's take the fifth rule. A root b times root c is equal to a root bc. That's it. And a times root b is equal to a root b. And the root 7 says that a root b times c root d is equal to ac root b d. Take note of this format. A times b root c is equal to ab root c. Capture these rules because we will be using it in our calculations. Capture the way I did it. Or if you can't see it, well, just go back and pause and watch the format in order for you to understand the multiplication of set. Let's move on. Multiplication of set. Illustrative example. Expand and simplify the following sets. So the first set is bracket bracket open, root 3 minus 1, bracket close, bracket another bracket open, 2 minus root 3, bracket close. So you take the first bracket, remove the first figure from it, and you multiply it through all the second one, like the second bracket. Multiply it through the second bracket. So root 3 times 2 minus root 3 minus 1 bracket 2 minus root 3. So 2 root 3 minus root 3 squared minus 2 plus root 3. So 2 cancels the root, getting 2 root 3 plus 3 root 3 minus 3 minus 2. You are getting our answer there, you know. So also another one. That's 2 plus root 3, bracket close, another root 3 plus 1. So it's actually, we are spreading it for the second one. So 2 times root 3 plus 1 plus root 3 bracket open root 3 plus 1. So 2 root 3 plus 2 plus root 3 squared plus root 3. So 2 root 3 plus root 3 and 2 plus 3. You know that will cancel out, leaving 3. So 3 root 3 plus 5 is our answer. Thank Check out to my next video. That will be on conjugate sets, and we are going to do rationalization of set denominators together with some other ones too, where we have equality of sets and other stuff. So stay tuned to my channel and you will get the rest of my videos in order for you to understand set well. Thank you for watching. Also, don't forget to like and subscribe. See you another day.